So now we're going to add the last IC, which is the counter. So just like the other parts, we need to know the power pins first. And so this I looked up online. The 7493 power pins are VCC is pin 5 and ground is pin 10. So I'm going to put the IC in. Remember, the notch is going to be marking pin 1. So put that in there like that. So pin 5 is going to go to VCC 1, 2, 3, 4, 5, and pin 10, which is directly opposite on the other side, goes to ground. Those are the power connections. So the next connection we have to make is the connection from the output of the AND gate to pin 14. So if you remember, the output of the AND gate was brought down to the LED with this blue jumper. So I'm going to jump from that point over to pin 14. Okay, so there's the connection there. Let's make sure we highlight that. Sorry. The next connection is from pin 1 over to pin 12. So for that one, I'm going to use a jumper. Okay, pin 1 to pin 12. Now we have these two pins. They're actually reset pins, and so if they go to a logic high, it resets the count back to 0. When we hook the final circuit up, when we hook that to the MyDAC, we'll be able to use one of the MyDAC outputs to reset it. But for now, we're just going to tie them both to ground so that they're not, they don't have any effect. So to do that, the pins are 2 and 3, right next to each other. So there's, in your wire kit, you should have some very small jumpers that just have 1 breadboard spacing. And you can take one of those and jump pins 2 and 3 together. And then we're going to take those and tie those to ground. So I need an orange jumper for that. Okay, so that takes care of that connection. Now the counter is basically wired up. The only thing we need to add now are these 4 LEDs. So what I'm going to do is I'm going to arrange them so that when we look at the LEDs, we see the binary number from most significant bit to least significant bit, just the way it's on the schematic. So we should be able to read the binary number across. So I'm going to use, I have to put the LEDs down here where there's space on the breadboard, and I'm just going to have them, each LED is going to be facing with the negative facing this way. And so I'm just going to notice how the negative pin, or the cathode, goes through a resistor to ground. So I'm going to use the resistor to jump to ground. All right, so each LED is just going to have LED resistor to ground. So now I just need to make the connections to the counter. So we'll start with the MSB, has to connect to pin 11. So that's a pretty long length. I had to make my own jumper for that. So going from here to there, let's go right here. And the next one is going to pin 8. So pin 8 is right here. Right here. So that's 1, 2, 3, 4, 5, 6, 7, a spacing of 8. So the gray pre-cut jumper is just the right length. And the next one goes to pin 9. So pin 9. From here, 1, 2, 3, 4, 5, 6. So the blue jumper is just the right size for that. And then the last one goes to pin 12. So pin 12 is here where the white wire joins. So we're going to go from here, 1, 2, 3, 4, 5. And the blue jumper is just the right. I'm going to kind of squeeze it in between these two wires here. There we go. So that should be wired up. Let's plug it in and give it a test. Give it a moment to power up. Looks like it's already lighting up, so it seems like it's starting with a... Okay, so every time I press the button, it should count to the next binary number. So that's binary 9, binary 10, 11, 12, 13, 14, 15, and then back to 0. And it looks like my debouncing is working pretty well. You know, yours might not work perfectly, so every so often you might see it skip a number. But remember, we're just testing the hardware at this point. Okay, so in the next tutorial, I'll show you how to connect this up to the MyDAC and use the MyDAC signals for the clock, and we're going to use the reset and the clock stop and start.